Welcome back, everyone. Dr. Sears here with another video, another lecture, and what we're going to be talking about this time, since we've already started to dive into roof control or ground control of uh, underground mines. I think it's a good idea to introduce the MSHA Roof Control Plan and Ground Support Review Procedures Handbook. Um, this is typically just called the Roof Control Handbook. And so a little bit of background on this. I'm also including another presentation. It looks internal to MSHA and a little bit old, but it goes through some of the why and hows of the roof control plan handbook. Um, Basically, just like my career itself, it kind of all started here at the Crandall Canyon mine disaster, and a lot of the research that us at West Virginia University were doing, the University of Utah, and of course NIOSH, were all going into a number of PIBs and pills and other memos related to roof control, and they decided that this needs to be put into a handbook to consolidate all of these because yeah, I mean for a while there it was difficult to keep up. New information was coming out regularly, and it was hard to sort of keep track of all the things that were going on. So I'll be putting that on the website as well. I'm not going to go through the whole thing. It's relatively lengthy, but if you want some more information about how this came about and how it's been implemented, um, you can check it out. So back to the handbook itself. If we come down to the table of contents, we can look at some general requirements for roof control plans. Um, the chapter 2 then follows up with how to evaluate ground conditions in underground mines. There are chapters on plan reviews, revisions, and 6-month reviews. And then there are several appendices. Some of these are going to be, relatively important to us in terms of the project, but overall, we're going to check out all of these kind of as we go along here. So, roof control plan is essential for controlling the roof, face, and ribs in underground coal mines. So that's what this is addressed to, underground coal mines. And so each operator is required to develop a plan that is approved by the district manager and must be suitable to the prevailing geological conditions at the mine. Chapter 2, evaluating ground conditions. There's a list of things, this is kind of designed for inspectors, right? So inspectors are reviewing the current plan before you go underground, that sort of thing. Then arrival at the mine, you'll be looking at the maps, taking notes of lots of things, depths, pillar dimensions, multiple seam mining, potential for bodies of water overlaying mine workings. So they're going to be looking at that sort of thing. Definitely the presence of over and under mining, that has a lot of potential to affect the active mine. So they'll be looking at things like that. So beginning at the portal, yeah, inspecting high walls for loose material, also, canopies and that sort of thing. Yeah, so when traveling to active areas of the mine, it's a good practice for, this is not just for inspectors, engineers, um, and other mine workers, looking for indications of deterioration. So, is there indications that the roof is moving? Are you getting cutters in the roof that show up as compression fractures along the rib? Um, are the ribs sloughing off, or is there excessive loading on bolt plates? Um, this is something that like I said, as engineers, we should be taking the time to be looking at out by areas, especially because they're travelways, right? Um, in the working area, examining the faces is very important. A lot of times, the first indicators of stress, right, are right in the freshly cut face. So that's where you need to be looking for indications of stress orientation. Now, we're not going to get into detail on that until we get to um, the rock mechanics class, but keeping an eye out for that will be important. In metal non-metal mines, they're a bit different. You need to be looking for the effectiveness of the support. Sometimes, a lot of times in metal non-metal, um, they're using supports like friction bolts and that sort of thing, which just use water to sort of expand up against the rock. So it's a little bit different, and you need to be looking at that, the mining method and that sort of thing. There's a lot of definitions in here. Back being the top in metal non-metal mines. Um, um, Plan reviews. This goes through all the review process, right? And so you'll Okay, so chapter 4, plan reviews. This goes through the process that reviewers will be taking when looking at roof control plans. All right, it's taking longer to get to the next before we go. Plan revisions um, are basically the same as reviewing plans. The operator doesn't need to revise the plan each time they add equipment, but they should revise it for significant changes. And so a lot of times, most roof control plans, and the equipment, will be listed in there as the same. However, for like support types, right? You're going to list in there as many support types as you possibly can. I mean, because you might be wanting to use it at some time, and you are limited to what's in the roof control plan. So, um, a lot of times you'll add, like I said, you'll add things in there you don't necessarily plan on using, but just in case you would need to. 6-month reviews are a thing. Now, some of the appendices are going to be important to us more so than inspectors. But they have a series of checklists. Um, so if you have complex roof control plans, um, all pillars are required to be designed in this country using ACPS, like we've discussed, the analysis of cold pillar stability. If they do not meet that minimum, or you are using an alternative criteria, which you can do, then that would need to be as considered a complex plan. Room and pillar retreat mining at depths over 1,000 feet of cover. Okay. Mines with a history of coal bursts, bounces, or bumps, depending on what part of the country you're from. And criteria considered unusual by the district manager. So this is when plans are required to go to MSHA tech support's roof control group for review and recommendations to the district, prior to that plan's approval. So these all have to go to tech support. And you should, for complex or non-typical plans, you have to provide data and engineering evaluations that support the determination that these systems, pillar design or whatever it is, provides a safe alternative, or safe working environment with the alternative plan. Risk assessment specific to the mining operation includes depth of overburden, the geology, strength properties. We'll take a look at that risk assessment matrix, and so when recommendations are made by consulting engineers, the operator should provide their reports with the assertion of adequacy. That the consultants um, fully cooperate with the plan reviewers in verifying conclusion. Data from currently available tools. ACPS, like I said, is the sort of the gold standard. LAM model, the laminated overburden model, which has been the software that I've used throughout my career, and because we did so much research with that, we developed a criteria that is considered to be um, equivalent to ACPS for review, right? There are other softwares out there as well, Rock Science, that sort of thing. If plans are based on empirical information, you can do an empirical design of your own mind, right? You can just take data and observe conditions, delineate successes and failures, all within your own mind. And if you would submit enough of that information, that to MSHA, and of course they would probably do a field evaluation, which it says, to kind of verify this. Those plans can be submitted as well. And I've never done this for pillar design, but I have done this for uh, rib support. I went to various places all over the mine, took photos, um, looked at what support was installed, saw what showed them what stress levels were expected to be there based on modeling, and yeah. After a site inspection, we moved forward with the rib control plan that I specified based on that. Um, so you can do that. Mm. Pillar stability analysis. We've talked about that just a little bit already. Um, like I said, pillar dimensions shall be effective to control the roof face and rib, and coal or rock burst. So. Like I said, most analysis, ACPS is just the way to do it. If it can be done with ACPS, then use that for sure. That's the um, but like I said, if you're using other programs, tech support will be taking a look at that and go from there. Pillar recovery, generally speaking, pillar recovery at depths exceeding 2,000 feet may not be appropriate. You may be able to do it, you may not be able to do it. So this is going to have to be, considered on, probably a case by case basis, depending on, over mining as well. If you're in a multiple seam situation, a lot of times, like I said, that area under the gob is de-stressed. Maybe you can mine that. And then at depths of 1,000 feet or more, the practice of pillar splitting may be particularly problematic due to high stresses and burst-prone conditions. If you remember, we do have some pillar splitting that was done in our project underlying mine that is deeper than 1,000 feet of cover. And since we've already looked at the ACPS results for that, you can see how that is potentially problematic. Final stump for retreat mining. We can get into that in this class too, I think. There are general guidelines for that you leave a pillar that's at least as, with the height ratio of 1, so at least as tall as, your mining height is, and they are designed to crush out, and, not impact, the caving of the roof or that sort of thing. And that's the idea. There are no, to my knowledge, there are no plans that allow the push out or the final stump to be removed, at least not in this area. So with that, where are we moving on to? Geotechnical assessments prior to retreat mining. This is important. So retreat mining, longwall or rim and pillar. They increase the stress experienced by the mine openings that are adjacent to the area that's retreated, the abutment loading. Um, so for areas to be retreat mined that are deeper than 1,000 feet of cover and long walls, I believe it's 1,500 feet of cover. So correct me if I'm wrong. You will need to do a geotechnical risk assessment for those panels prior to retreat mining. You'll need to do underground mapping, which is the most important part, and record the most important and most significant features related to roof control, any geologic features that you would see, um, the current conditions. Is the roof sagging? Are the bolts loaded up? Um, are there, cracks? Uh, what roof support's installed? And like I just mentioned, any unusual weight on the support. So you need to know what's in there. You need to make sure that see if the secondary support was installed on advance, or are you installing it as you retreat? Because most likely you're going to be putting some form of additional roof support in the intersections, most likely cable bolts. Record any unusual mining dimensions if certain intersections are getting wide or something like that, or places where the MRSs won't reach. You're going to have to get the turtle shells, the extenders for them. If it's more than that, you're going to have to come up with another plan, but some timbers, which would be huge, with that kind of height. Yeah. So, and then that map, then has to be, of course, posted at the mine, and also trained on, right? So there has to be training provided to anyone working on that section about um, the hazard map itself that you created, and potential burst hazards, and so training on. Okay, and training is required on the hazard mapping itself, as well as indicators of a potential for coal burst as well. So that all has to be trained on for every miner that will be working on that section. The mine's historical record is important. A mine that has a history of roof falls, a history of rib falls, or a history of coal burst, then you would obviously be looking out for either of those things. Non-injury related falls. Okay. Underground inspections for roof control plans. Roof supports listed in the plans. Like I said, you need to be putting in all applicable supports. And like I said, even those you may not be planning on using. Accident investigation. Rip fall hazards. So, just recently, there have been quite a few rib fall fatalities. They've gone down, which is good, but it's still sort of our, area that probably needs the most work, compared to roof falls. So a lot of times you'll see rib fall fatalities that either have multiple seam interactions, so you've got elevated stresses on the ribs, large slicking sides in the coal, so you'll have sort of a fracture plane, and it is slicking sided and has basically zero friction associated with it, and allows large blocks of coal to slide. Unusually high places, so you've mined out for an overcast or belt drive or something like that. Pillar corners can be potentially unstable, And then, of course, the probably the number one um, sort of factor is rock brow, or a brow on the rib, where you're taking excess height from the roof, for equipment clearance and all that. But then that coal fails out from underneath, and then you're left with a brow that's hanging there, and that needs to be supported, or instead if it falls, is one of the more dangerous aspects of roof falls. Coal burst hazards. So, like I said earlier, um, coal bursts are a risk for mines that are typically um, deep. It is possible to have bursts that were shallow, but experience shows that it increases with depth. Most are over 1,000 feet. The the universal characteristic of a burst-prone environment is the presence of highly stressed coal. That coal can be stressed in a number of ways, right? Overburden depth, that's the overall stress level. Um, but pillar design, if your pillars are too small, they'll get overstressed, right? Multiple seam interactions, that increases stress or decreases it, but um, so it goes either way. And geology is also important. A lot of times there's a strong roof or floor, right? Not all, but a lot of times. You can also have geologic features that are associated with them. Sandstone channels, faults, um, particularly out west. And I believe this was in the uh, one presentation earlier in the semester, where coal bursts just tend to happen on one side or another of faults in certain areas. Um, so, universal characteristic is highly stressed coal. How it gets stressed, there's a number of ways. The thickness of the inner burden is important, and what type of remnant structure is there. If it's just a gob solid boundary, so you have gob against a large barrier, um, you'll typically see less stress than if it's loaded from both or all sides. So a remnant or an isolated pillar, an isolated remnant would, especially if it's large enough to store all of that load in it, can get very highly stressed. Yep. Uh, you know, empirical or numerical simulations should be part of this assessment. The geology, how close you are to a strong unit of sandstone. Mine layouts can be important, and then conducting the risk assessment itself. There are levels in the. I'm hoping it's like right here. Here we go. Here we go. The burst risk matrix. So this is what you're going to fill out, right? So, and it's low, moderate, or high. You can go green, yellow, red, whatever. So depth of cover is this. Pillar design, does it meet the NIOSH criteria, including the barriers, or does it not? Multiple seam interactions, when we get into those in ACPS, you'll see green, yellow, and red for good, okay, and worse. Green being you should be fine. Yellow, you're going to need supplemental support. And red being you may want to not do it. Your roof conditions, weak shale, typical western or central app, and then strong, thick, massive strata near the seam. So maybe like Utah or something like that. But you can also get this in a central app as well in some places. Floor conditions, from weak to strong. Other geologic factors, they're just all in the high. If you have these, they're just all in the high category. How you are recovering the pillars. Development or partial recovery is low. typical Christmas tree or outside lift. We'll look at those layouts in the future, but that's just your standard, typical retreat mining cut sequence. And then finally, high would be if you are closing in the center. So typically, when we extract pillars, we go from left to right or right to left. And in eastern Kentucky, if you are mining with continuous haulage, a lot of times they close in the center because they can't reach far enough to stop mining on one side or the other. To do that, you have to use a shuttle car, right? So your bridge system kind of ends, and then you're running a shuttle car back and forth to it. So it's they don't typically want to do that, but it can be done if the burst risk is too high. Also, barrier pillar extraction. Um, that's definitely high. That was what they were doing at Crandall Canyon when that burst occurred. Uh, when I went in the Harris number one mine towards the end of its life, in fact, I think it was only open a couple weeks after that or so. That's what they were doing there. We were retreat mining the barriers um, out of that mine on the way out. But it was a lot softer. When I say softer, I mean the roof and floor were a bit softer in there than what it could have been, right? So there were places where it had squeezed together so much the roof was just touching the floor, and eventually they were, mining their way in they'd have to grade the floor out to get back in there and mine more. And eventually, when they had to mine their way out, that was just the end of it. But so that's what was going on. This sort of barrier pillar extraction, you can get a lot higher stresses there. Um, and then split and fender pillar recovery, I haven't seen that being used, but okay. Panel width is important. Remember, the wider your panel is, the higher the stress at the center of it. That stress level increases with the square of the width. So it increases pretty rapidly as you get wider. And so there's less than 350 feet, greater than 500 feet in between. And then, of course, the past history. There. And past history. Oh, and then for longwall mines, using yield, abutment yield, or interpanel barriers is appropriate for depths of cover exceeding 1,200 feet. We'll talk about that at some point. ACPS, yeah. So the rest of it's kind of the same. But so it's similar, very similar for both longwall and room and pillar mines. And then once again, the training, monitoring, and record keeping. So if pillar recovery conducted and overburden exceeds 1,000 feet, or development or longwall mining exceeding 1,200 feet. When I said 1,500 feet earlier, I was wrong. It's 1,200 feet. Then you do have to provide training to persons that work on that section. All right, and it's prior to conducting work on that section. And you have to cover potential hazards associated with mining deep cover. So that includes coal bursts, right? With emphasis placed on, the increased potential for them and the actions that need to be taken when those indicators are present. And some of those indicators, the most likely being precursor events, right? So small bursts that occur leading up to a larger event, you really need to stop mining and you really need to tell somebody. An instructor knowledgeable about the potential hazards and indicators. You don't have to be an approved instructor to conduct the training, but you have to be knowledgeable. And complete a 5023 form. Section has to be monitored for indications of an increased burst. Like I said, the occurrence of small coal bursts is the most likely If you experience increased uh, strength in the immediate roof, like roof boulders, you can sort of track the strength of your roof to some degree on how easy or difficult it is to drill, how many bits you're going through, that sort of thing. If you're also taking a bit of roof rock, you can look at minor bit usage too. I did that before because we were in a part of the mine, we started going through a lot more bits, and yeah, we were getting sand down on top of the coal. So um, a significant change in the amount of seismic activity emanating from the roof or floor. Typically, that is in the direction of less activity. You know, if you're just mining along and everything sounds like it normally does, then that's fine. But a lot of times, what you'll experience is a lack of sound, a lack of vibration. And that can indicate that energy is being stored and could be released in a more violent manner, right? And then finally, there's this unusual sort of red dust at the rock coal interface. Um, I can explain what that might be in geological lab terms. But basically, if you take a piece of coal and you rub it on a piece of ceramic, it leaves behind a mark, and that mark's called the streak. And the streak of coal is red. And so the theory is that as this coal is ejected from the rib, it rubs against the rock and leaves behind the streak. But it's not always present, so it may or may not be there. And so that all has to be trained on. Um, so if you were, doing a mine like we are for our uh, class project, it's deeper than 1,000 feet, and you would you would have to do this process for that mine, and so we will include this in the project as well. So we'll be filling out the burst risk matrix and coming up with a little sort of plan or lesson plan to address the training requirement. And I know I mentioned previously about training on the hazard map as well, and so it's not explicitly listed in here, but that's how I always conducted my training. Was I started with it. I was like, this is what I found when I walked around everything, and just started from there. So okay, so this may have gotten off the rails a lot, but it's something that we do have to do, and yeah, I'm just gonna I'm just gonna stop there, and we'll pick up with this next time.